Hello, my dear students, and welcome to the Semiconductor Devices module. This is our zero lecture in the Semiconductor Devices module. It's, as usual, a 12-week journey where we are going to investigate in more depth some foundational or fundamental electronic devices that is commonly used in our commercial industrial electronic market. Actually, we consider this module as a bridging module between what you already have learned in the materials, electronics 1 and electronics 2 modules, and what you are expected to learn in the VLSI module in your next semester, as well as if you choose an embedded systems as an optional mode. So it's a bridge. In this device, or let's say in the previous device, you have learned the electronics fundamental from a macroscopic point of view, from a circuit perspective. Now it is a time to narrow down the scope. It is time to turn to a microscopic view. We are interested in investigating the semiconductor behavior of our foundational devices. What I mean usually by foundational devices is our transistors. As you surely know, transistors is considered as the main building block for any analog or digital circuit. So the main scope of the module will lie in the field of understanding the semiconductor behavior of different type of transistors. We give a special interest to a metal oxide semiconductor field effect transistor, or what's abbreviated by MOSFET. And then we go also to other types of semiconductors like bipolar junction transistor, like tunneling field effect transistor. Also, we consider some other interfaces like the metal oxide interfaces or metal oxide semiconductor interfaces and its effect on that device's behavior. But in order to start all these investigations, we have to have a common ground. So our common ground will be considered in first, reviewing what we already have learned in the material course, and then start with a very simple device, which is the PN junction. This is generally the scope of the material. In this lecture, lecture number 0, we are going to settle the main protocol of our module. How is the module will be implemented or will be conducted? What is the time frame of our module? How we will access the lectures and tutorials, where we can find the material lectures, the material for the lectures and the tutorial. What about the assessment? All these questions will be answered in this 0 lecture. So now please let me share my presentation slides and start with you the journey of our semiconductor module. Okay, welcome back, my dear students. This is our 0 lecture for the Semiconductor Devices course 20ELEC05H. And let's now start the 0 lecture. Okay, so what is the correlation between studying semiconductor devices and the electronic industry? This is maybe the first question we have to answer in this 0 lecture. So generally, whenever you have an electronic circuit, the first simple thing comes to your mind is this IC structure. I mean, IC is what's called the integrated circuits. This integrated circuits is a compact circuit that include a huge number of gates or electronic elements, maybe also passive elements like resistance, capacitors, and so on. And also, you can find this IC everywhere in your computer, in your laptop, in your smartwatch, whenever you will turn around, you will find ICs everywhere. So this IC, or this integrated circuit, consists of what's called gate, what we know by the electronic gates. I believe you already have a very good experience with that whenever you deal with digital design, computer organization, computer architecture, and all these modules. You already have, or you are already familiar with this electronic gates. This electronic gate is consists of a series of very important element, which is the transistors. Transistors, as you can see here, this is the series of transistors connected together to form an electronic gate. By the way, one of the main scopes for the VLSI course is to study how you can format, how you can structure an electronic gate using transistors. Herein there is a technology which is very famous. We will highlight it in a very quick manner in our course, but it will be studied in more detailed manner in the VLSI course, which is called the CMOS technology, or called the complementary metal oxide semiconductor technology. And there is another also approaches, but by the way or another, you will be or you will study these structures in more detail whenever you start your VLSI course. Okay, so this is the transistor. A transistor is a combination of a material with different properties. So in the transistor, we have semiconductor materials forming the source and the drain. We have an insulator below the gate contact, and also we have metals to form the electrodes or the contact. So it's a series, or it's a combination of materials with different properties. And whenever you change the properties of the material, you will change the behavior of the device. This is the transistor. So simply we are studying, we are studying this fundamental devices, which is the transistor. We are studying this structure because this is simply the main building point of our electronic gates, which is the most important starting point for any digital electronic industry, as well as analog industry, because actually we're still using MOSFETs in our analog industry, and sometimes for power electronics application we are using bipolar junction transistor, or BJT. So basically we are now starting from scratch. We are now applying what's called a bottom-top approach. We are interested in studying this device, which is a transistor. Then in the next step, whenever you go to the VLSI, you will scale it up to form a gates. And then these gates can be used in digital electronics, where you can know more whenever you start your embedded system course. This is simply our bottom-up approach, where you are now terminating your electronic trend in this curriculum using these three courses. I mean, the semiconductor course, then the VLSI, and an optional module, which is embedded system. This is simply how life will go on. So now let's show this in the curriculum. You already have studied electronics 1 in your first year, and then you have studied the materials and also electronics 2. In the previous semester, I believe you already started, or you already had your measurement course, and now we are in the semiconductor devices. And finally, as I mentioned, we have the VLSI and the embedded system. This is simply the trend of the electronics in your curriculum. So what we are going to learn, what is the course outline, what we are going to learn, which devices we are interested in. So we already have materials. We already studied material before. So what we are going to do is just a very quick flashback. I believe you already remember most of this information before. It's a flashback. It will take something like 1.5 weeks in order to flashback all the needed information regarding the materials. We will actually brief the module to those information which we are interested in. So please expect that many of the material lectures will not be revised, because simply we are not going to use them in this module. So we just brief the prerequisite, let me say, in order to study the semiconductor course. Then we go to devices. We start with the PN junction. Again, this is a foundational device in order to make you understand the main concepts of semiconductor devices, the drift diffusion model, the IV characterization, and all this stuff. And then we have the MOSFET. We have also the BJT, or the bipolar junction transistor, and we have also the tunneling field effect transistors and some other in-between devices and structures. So this is simply the outline. Myself, I will be as a module leader. It's a for me a pleasure to join you in this module. And actually, it's also a pleasure for me to have Engineer Zahra Ismail as the main TA for this module, along with also Engineer ELEC05H, who will continue the last 3 or 4 weeks of this module as also a module TA. Oh, let's go to another topic. Let's go to what you expect from this module. Sorry. First, we have a semiconductor fundamental course, a semiconductor fundamental lectures, as I mentioned, for 2 weeks or exactly 1.5 weeks. Then we will go to the PN junction. After that, we will go to the MOSFET, and finally with the BGT. Again, we have still some small lectures to cover some other topics like the tunneling field effect transistor, and also some topics like the also the semiconductor oxide and semiconductor metal interfaces and the heterojunctions and all this stuff. Regarding the assessment, we have 3 types of assessment as usual. We have an in-class test by week 9, which is weighted 20%. We have a project by the week 12, which is again weighted 20%. Maybe I will discuss more about the project in this lecture later on. And also we have an unseen experiment, an unseen final exam, which is weighted 60%. This is the overall structure of the assessment in this module. Regarding the project, let me first start talking about the project now, and I will talk about later on in while we are making a tour over the e-learning page. But for the project, we are going to use a very famous website, a very famous online simulator called NanoHub. I am now asking you please to start making an account over the NanoHub. It's a free account, by the way, and I will provide you with all the data and all the link needed. You will find a series of selected topics where you will have to select one topic per group, of course, and then in corresponding to the topic, you will find the appropriate link in order to access the experiment. This is for me very interesting because you are not asked to do any sort of coding. I mean, it's an input-output relationship. There is a backstage simulator who is doing this simulation for us. What we are going to change inputs and detect outputs. This is simply like that. Again, our course is not a programming course, so we are not interested in building a very huge MATLAB code in order to do some sort of task. I believe you already did this maybe in the signals or the communication course. What we are going to do is to understand and to interpret data. I mean, you are changing, for example, the length of the channel in the MOSFET. Then what is the effect on the IV curve? What should you do? You will not waste your time in building codes in order to investigate or in order to map mathematical equation into a programming language. This will not happen. You will just monitor the input-output relationship. And this is, by the way, very easy and very difficult. Very easy because what you are going to do is just changing input and get output. But it's very difficult because you have to understand everything very deeply in order to answer questions. This is how the project will run. So this is the project. Regarding the allocation of the tutorials and the lectures, we have a lecture on Thursday by 11 a.m. every week, inshallah. Okay, so we have our lecture on Thursday every week by 11 a.m. Again, it's for 2 hours as usual. And we have also our tutorial on Tuesday from 1 to 3, delivered by Engineer Zahra Ismail and the Engineer ELEC05H. This is the Zoom link that is dedicated for our module. So you can access any online session in our module using this Zoom link. It's a generic one Zoom link for everything. So you just need to memorize to keep it maybe in your mobile, in your laptop or wherever. So online lectures, online tutorials, project milestones, office hours, whatever it is, everything will be operated in using the Zoom. Okay, so this is the outer frame of the e-learning page. So this is an appropriate time now to start sharing the e-learning page. Let me prepare it for you. I think it's already prepared. Okay, just need to check. Okay, that's perfect. Then we have now to share screen to this e-learning page. So this is our e-learning page, and let me also operate my virtual laser pointer here. We have, this is my contact. I believe you already have, or you already know all my contacts. We can turn this off. Okay, this is the module leader contact you already have. This is the module specification. And now this is a weekly time plan. I think this is somehow interesting for you to see the weekly time plan. Okay, so this is our weekly time plan as usual. You already used to have this time plan in my modules, if you remember. So we have the lectures, the tutorials, and what about the projects and the project milestone. So let's keep more focusing on the project. Tutorials and lectures are running in a normal way. However, for the project, your first deadline will be in the first week, where you have to select your group, your project title, and submit your selection. This will happen through a Google form link that will be posted over the e-learning. Then you will have two milestones, I think. The first one in week number 6, and the second one in week number 8. In these milestones, this is somehow a follow-up meetings to discuss what progress you have made in your project. What is your next step? If you have some questions, if you have some difficulties or whatever it is. So these are two milestones in order to follow up the project. And then we have an in-class test on week 9 to be decided, of course, the venue and the exact time by the department. And finally, we have the submission of the project report and the discussion in week 12. So this yellow slots with red font represents the main important steps, either the deadline for allocation, the milestones, the in-class test, and the submission discussion. Otherwise, in the first two columns, you will find all the lectures and the tutorials. By the way, we have 2 lectures with a conflict with an official holiday by Thursday. So this will automatically be shifted to your day off, which is, I believe, on Saturday. So this will be highlighted here in red, just to make sure that this is a shifted lecture due to an holiday. So I think this all about the time plan. Let's now return back to the presentation slides. So let's share. Okay, no. Let's return back to the e-learning page. I'm sorry. Let's turn back to the e-learning page. So the e-learning page. Okay, let's stop here sharing, and let's do to the e-learning page. Yes, this one. Okay, perfect. Now you can see again the e-learning page. So everything is here as I mentioned. Again, my laser pointer is working. So this is a previous year exam, and this is a the coursework assessment guidelines. The reading list, I will mention it in my lecture after a few minutes. And again, this is a Zoom link. I just show it to you in my presentation. This is the Zoom link where you can access every online session delivered in this module. This is the lecture part, lecture scripts. I believe you already have some knowledge about what is lecture scripts. We already used it in the material course. And then we have the recorded lectures. So all the recorded lecture links will be here. And also, of course, it can be accessed over YouTube. Interactive learning tools. We will have some very interesting interactive learning tools in this module. Tutorials and the project. Here you have two important files. The first one is the project. I'm sorry. Yeah, this one. So the first one, this is the project guidelines. So you know everything about the outline of the project, how you can construct your report, and all this stuff will be found here. And we also have another document, I think, which is the project topics. So let's have a look on these project topics. Okay, perfect. Okay, let's share screen again to the project topics. Yeah, this is fine. Okay, that's perfect. I think you can now see the project topics. So as I just mentioned during the presentation, it's very easy. You first go to the NanoHub and create a free account. Then what you are going to do is just to select one of these topics. Again, it's a group-based project. And then the simulator corresponding to the project you select is in this link. So just click the link and run the experiment. You will do some, of course, some effort in the beginning to learn somehow about the interface. I can help you somehow, but by the end of the day, I believe this will be an easy task. Don't worry about it. So this is simply the project selection. Now let's go to the slides again. Okay, this is the slides, and now this is the course outline, as you see already in the e-learning page. So I think nothing new here. Let's go to the next slide. Okay, so what about the reading list? What about the reference? We have two main references, two main textbooks. The first one, you already have a look about it when you study the material course, which was CASAP, Electronic Material and Devices. If you already access the references, then you should know somehow this reference. This reference maybe, or I prefer this reference for the first part of the module related to the material. But for the devices, I would appreciate using solid state electronic devices for treatment. I believe this is somehow a very famous and a very standard reference in the semiconductor devices modules. It's somehow old, but it's, as I mentioned, it's a fundamental reference. So I would recommend using solid state electronics. Of course, you can use any other reading reference in your module specs reading list. So this is the end of the first, or the end of the zero lecture. I hope that you have now more clear vision on the module structure and all this stuff. Again, I will be very happy to receive any of your questions, either using email or using any physical meeting. Maybe during the live lecture, I will update you exactly with my exact office hours. We will have different types of office hours, either an online office hours or an on-campus office hours. So you can access me using either the online office hours or the on-campus office hours. Thank you very much, my dear students, and waiting to see you in the first lecture, while we are going to review the different semiconductor material fundamentals. Thank you very much, and see you later on.